The third most common topic on the Algebra 2 regions, in my opinion, are graphs of special functions. So when I say special functions, I mean exponential functions, log functions, trig functions, and sometimes even really big polynomial functions, right, where the degree is much higher than 2. And all of these graphs have special features, so we're going to talk about them a little bit individually, remind you of some things you should pay attention to when you talk about them. And the first is question number 4, which talks about exponential decay. Now, when working with an exponential function, remember, it is always a function of the form y equals a times b to the x, right? A will always be your initial value. B is the base of your exponent, and basically if that b value is greater than 1, you're going to have growth. So your numbers are going to start off really slow, and then all of a sudden they're going to increase rapidly because you're repeatedly multiplying by a big number. Now, if b is in between 0 and 1, meaning a fraction, a decimal, something of that nature, it's going to be decay, which means that it's going to start off really, really big, decrease rapidly, and then after a while, it's going to level off because you're eventually multiplying really, 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 really small numbers. So that's what this question is talking about. It says, which function represents exponential decay? Now, you always have the option when asking about decay and growth to check your graphs. So you can type each one of these into your y equals, y1, y2, y3, y4, and check to see which one decreases over time versus which ones increase over time. Now, I'm going to talk about the algebraic way to do this, which involves some exponent properties and making sure everything is in its right place. So let's start with number 1, which is 1/4 to the negative x power. Now, at first glance, a 1/4 raised to an exponent implies that it's going to be decay. However, this exponent has a negative on it. And what's important to know about a negative is that it takes whatever the base is and it flips it. Numerators become denominators, denominators become numerators. And so this 1/4, if I were to split up the exponents, right, instead of having negative x, think of it as negative 1 times x, and apply that negative 1 to the 1/4, that 1/4 becomes a 4. And so 1/4 to the negative x power is actually the same as 4 to the x power, which is the growth picture, okay? So although it looks like it could potentially be exponential decay, it's not. Now, for question number 2, we're going to do the same thing, right? We have a 1.8, which typically indicates growth. However, we're going to split that negative x into a negative 1 times an x, because that's how exponent powers work, right? You multiply exponents when you have a power to a power. We're going to take that 1.8 and raise it to the negative first power. Now, that's going to be 0.55555 repeating, aka 5/9, which I got using my calculator. And remember, 5/9 is less than 1 and greater than 0. So this base indicates that it's decay. So I believe we found our answer, but let's double check the other two. So in these two, we do not have a negative in our exponent. We can still split up the x from the numbers that it's attached to, but it is not going to switch positions like the negative does for us. So in this question, that's like taking 2.3 and raising it to the second power, which, if we do that, gives me 5.29 to the x power, which is greater than 1, so that will also be growth. For this one, x over 2, remember, is the same as, 1/2 times x. So if I give that 1/2 power, to the 4, that's taking basically a square root of 4, because remember that denominator becomes your index. So it's like having the square root of 4, which we know is 2, which again indicates growth. Okay, so in terms of determining that, make sure you're really exploring your exponent rules to see each one fully, and also make sure you use your calculator to verify that as well. Now, other things to remember about exponential functions is that they can have what's called an asymptote. Remember, I said how exponential growth function starts off really slow and then increases rapidly. Well, the place where it's going really slow is an asymptote. And for most graphs of this form, the asymptote is y equals 0. However, if they add a constant to this expression, that number is now going to become your asymptote. So asymptote would be x is equal to c, whatever that value is, whether it's raised up or down. So that's a little bit about exponential graphs. Remember, the a is your initial value, so that's something to always consider. But now we're going to move on to question number 13, which, looking at this oscillating picture, is a graph of a trig function, right? Trig functions are sine and cosine. They repeat over and over again. And this particular question is talking about a cyclist who pedals a bike at a rate of 60 revolutions per minute. The height h of a pedal at time t in seconds is plotted below. So the y values are the height of the pedal. So thinking, I guess, feet or inches, whatever it may be, 1, 2, 3, 4, 5 inches for a bike pedal would make more sense. Whereas t is the time in seconds it takes to go. So if you think about a pedal, right, you have a pedal here. It's starting at base level. You raise it, go up around the circle, then you go back to that base middle level, then you get to its lowest point, and then all the way back around. That cycle right there basically means that we're doing this with the pedal, going around in a circle. And we know that that's going to repeat over and over and over again. So each one of these is called a cycle of a graph, of a trig graph. In this case, it's a sine cycle because it's starting at your midline and ending at your midline. Remember, cosine graphs start at your max or min and end at your max or min. And the question itself verifies that, right? H of t equals 5 times sine of k to the kt. Now, some other things to keep in mind about this function. This number in front here is what we call our amplitude. Well, at least the absolute value of that number, which means that is the highest. Each bump of our trig function is going to go a unit 5 units. So here, since we're starting at 0, the highest we go is a positive 5, and the lowest we go is a negative 5. That will change as your midline changes. Now, what we're missing here is k. Now, what is k? Well, k typically refers to our b value on a trig function, and it's basically the number of full cycles in a 2 pi period, right? So how many full cycles of these will we see in a 2 pi period? Now, I don't see 2 pi anywhere on this x-axis, so we're going to have to be a little bit creative. Now, something we should know is that this b is related to the period, the length of one full cycle, by taking 2 pi and dividing it. So in this case, I'm going to divide it by k. So the length of one full cycle on this graph, if we see, I'm going to erase it right here, is a 1. So that means my period is equal to 1 unit. If I wanted to solve this mini proportion, right, I multiply both sides by k, I get k is equal to 2 pi. So we have found our answer here, which corresponds to the correct period of this particular function. Now, other graphs that you should be aware of are log functions. This regions didn't have a log graph, but remember, logs and exponentials are inverses of each other, so they share similar features. So just like this has a mistake. Just like a exponential function has a y equals c asymptote, a log graph is going to look like this on its side, and it's going to have an x equals vertical asymptote, which is going to correspond to whatever is inside the log. Okay, remember with log functions also to draw the tail at the end. Your calculator makes it a hard stop because it has a hard time graphing along that vertical asymptote. So make sure you're keeping that in mind. Now, some other problems on this Regents that you should look at for January 2023 is number 3, 4, 13, and 36. So make sure you use some of these skills to solve those questions.